In a minute.
So good morning, sir.
Yeah, yes, Professor Senthil Kumar.
Good morning, sir. Good morning, sir. Sir, 2 minutes, sir. The students will join us. Okay, sir. 2 minutes.
Sure. You can stop recording. Record just whenever Professor. He will inform you, and then you please start recording.
Login பண்ண சொல்லுங்க first.
So, Professor Senthil Kumar, whenever you say yes, we will start.
Okay, so 1 second, sir.
Sure,
I will inform you, sir, please.
Fine, fine.
So shall we start, sir?
Yes, we are ready.
Okay, sir. We can start, sir, please.
Hello. Good morning, everyone. On behalf of School of Engineering and Applied Science and Hindustan College of Arts and Science, Coimbatore, I, Professor Kuntal Patel, welcome you all. Under the Industry Expert Lecture Series, today we have organized this session on Neoteric Frontiers in Cloud and Edge Computing. We are fortunate to have Professor Rajkumar Bhuya as an expert for today's session. Thank you very much, Professor Bhuya, for sparing your valuable time and joining the session. Now I invite Professor Sanjay Chaudhary, Dean of Students, Ahmedabad University, and Professor and Associate Dean at School of Engineering and Applied Science to introduce Professor Bhuya. Over to you, Professor Chaudhary.
Yeah, thank you, Professor Bhuya, for accepting our invitation for such a interesting and very relevant talk. And I'm sure all the students as well as researchers who are going to attend this talk, as well as when they listen to this talk, they will make the best out of it. But please allow me to introduce you formally, because it will be our pleasure to introduce you with young students at Ahmedabad University as well as the Hindustan College. Professor Rajkumar Bhuya is a Raymond Berry Distinguished Professor and Director of Cloud Computing and Distributed Systems Laboratory at the University of Melbourne, Australia. He is a founding Chief Executive Officer of Anika Software, a spin-off company of the university, which is very, very successful in bringing innovations, and at the same time making this product very, very successful in terms of its use in industry and academics and research. I'm really, I really feel privileged to make this statement that Professor Bhuya is a highly cited researcher, and he has published more than mind-boggling number, 725 publications, including 4 textbooks. And one of your textbooks, Professor Bhuya, we are using here also for our course on cloud computing, your book on Mastering Cloud Computing by McGraw-Hill. Professor Bhuya has also done various leadership roles for setting up of very interesting research for wide and broad impact, including his leadership role as a foundation chairman of the IEEE Technical Committee on Scalable Computing and various leading IEEE and ACM conferences. Indeed, it was my pleasure to work with him on our editorial book on research advances in cloud computing, which was published by Springer in the year 2017. Not only he is very active with his academics, research, societal kind of contribution, leadership role in research, he is also very, very active with his spiritual aspects of human life, including Bhagavad Gita and Srimad Bhagavatam. Professor Bhuya, we feel privileged to have you with us, and now I request you to please start your talk. Thank you very much.
So thank you, Sanjay, for inviting me to be part of this event. Of course, our colleague from Senthil, he was also very keen on me do this seminar jointly between multiple institutions. So thank you again for this opportunity. So it is a privilege to associate with all of you. So let me share my screen. Oh. So do you see just single screen or multiple screen?
Yes,
we can see your screen.
Just one, right?
Presentation is still not visible.
You are seeing one small and other one, or just one?
One screen, and there are in the side there are small verticals.
Okay. I'm just changing.
This is fine, sir. Your presentation screen is visible now. A single slide.
Yeah, one single slide is visible, but not that other one.
Correct.
Just only one. Okay.
Yes.
Okay, that's good. So, so thank you again for this opportunity. So I'm going to discuss about some of the recent advances in cloud and edge computing, which are driven by requirements of applications from big data and Internet of Things. So you can say covering the so-called emerging data science application and IoT application, and what advances we need to do are there recently in cloud edge computing. So that is the focus. It is more of a technical talk, At the same time, I will also illustrate the usefulness of this technology for this big data and IoT applications. So along with a few case studies. So this is a brief outline. So I will quickly introduce you various computing paradigms that have been emerging during last 50 years, but I'll just primarily just quickly bring you to cloud computing. Then we will take a look at the state of the art of cloud and their application very briefly. Then we'll also take a look at some of the new trends in technology and application. So how they impact on the architecture of cloud systems and solutions that are developed and how they help rapid creation of application. So that is the focus. In that context, I will discuss briefly MarketOriented Architecture. Then we'll also take a look at Anika as a cloud platform that one can use to build solutions for different markets, different application areas. Then we will take a look at some of the new trends in IoT very briefly. So because there is a change in computing paradigms, earlier IoT applications were mostly cloud-centric IoT application. Now this is being changed to edge-centric application, especially when there are requirements of real-time services. So in that context, we will take a look at the concept, and of course, I will focus more on some of the solutions we created to illustrate that this is not just a theoretical idea, but also practical solution. So we'll touch on both real technology for building real application and also a simulator called hypoxia. Then we'll conclude at the end. So this is the plan for next 50 minutes. Okay, we'll start with this brief intro. So you can see during last 50 years, so there have been various kind of computing paradigms how introduced and they become successful. Then of course they led to the emergence of the new one. So this is how the IT advances anyway. So as you all know, during 60s we had mainframe computers. Then fast forward to now 2020, the most dominant one is cloud computing. So essentially what cloud is all about, providing access to remote computing and application services as paid subscribe services. You subscribe to those capabilities and use it and pay as you go, pay for what you consume. That's a utility model. So rather than owning everything yourself and managing and using, but you can actually go for this model of cloud service. So just like electricity is utility, then water is utility, you get it at cities. Similarly, you get computing also as utility. So that is the model. And of course, in between, there were many advances that we all are familiar with, like, for example, client-server computing and World Wide Web. All of them have actually helped the emergence of this cloud computing. So this is a big disruption during last 10 years. So much of advances happened. So we'll take a look at briefly, applications that are powered using cloud. Then we will take a look at the new applications and the new technological trends and how they influence on cloud architecture. So then with ubiquitous nature of possibility of deploying IoT everywhere, billions and billions of IoT devices everywhere, which also means that we need to look into better way of creating smart services and that can be delivered in real time. So that requires sort of integrating edge and at core of the network and the cloud and so on. So that is a much more popular topic these days. So all these advances that we see during last 50 years, they have taken place primarily driven by earlier driven by big scientific and big military applications, but now they are driven by big population application. So this is a interesting phenomenon that is happening globally. So when we take a look at this cloud architecture, so what you see is essentially somewhere in the networks you have compute services, application services, a large scale computing capability. You as a user subscribe to those services, use it and pay for what you consume. So that is it's a very simpler approach. Of course, you might have been subscribed to a service provider one. That doesn't mean that the service provider does everything for you. The service provider might in turn be using capabilities from other providers and putting them together and delivering as a composite service. So this is how today most of the cloud applications are crafted to deliver service to end users. Of course, end users are not aware of all this fact of distributed multiple cloud computing data centers that are put together and application services provided in a seamless manner to end users. And this architecture is actually used by so many of those cloud services, including the Zoom software that we're using today. So Zoom is a cloud-based video conferencing software. So what are the applications that are already powered by cloud? There are so many of those. From the traditional business application, commercial, scientific application. So even as simple as this, CRM, customer relationship management, enterprise resource planning, or e-commerce. These are applications running on cloud already. So which is really a success of cloud. Then the application that consumer world uses, just the large common people, such as Twitter. Twitter is a micro business service running on a cloud. Then even the Facebook. Many of us have accounts. Sometimes we don't have a passport, but we have a Facebook account. So especially during last 18 months with this COVID pandemic, so many people have moved to virtual friendship, virtual communication, all these, these applications running on a cloud. Then the Dropbox is a cloud storage service that harnesses the power of multiple cloud storage data centers, also your own storage, then provides you, reliable and shareable storage drive, if you like. So this is really success of cloud everywhere. Then looking at what happens on internet, especially applications that are powered by cloud, and what level of service is being used during just 1 minute. In 60 seconds, what happens on internet? That was for 2020 and 2021. I just shown here. You can see, in a second, you will see, more than 1 million people will, start using this Facebook. That means so huge. And then, of course, in terms of YouTube. So huge number of people are actually accessing, close to 5 million people are simultaneously accessing YouTube content. So the YouTube is hosted in a cloud. Then this Twitter and so on, you can see, plus many e-commerce applications, massive hosted in a cloud. So what it means is the cloud is becoming successful, and then numerous applications are already powered, which is a great thing. Okay, and then whatever architecture today is, that is already meeting some of the application needs. So meanwhile, let's take a look at some of the latest technological trends and application trends, and how will they influence on the cloud architecture. I will show you as you go along, the traditional architecture along with this newer technological influence on the architecture. So traditionally, this in the beginning I mentioned is the virtualized computing infrastructure. Yes, it is virtualized, but however, if you are looking for a real-time operation, the boot time of that virtual machine is sometimes take 2-3 minutes. That may be too slow. So especially if you're composing rapidly application services and delivering. So therefore, there is some concept called containers and microservices came into picture. So this is the latest popular technological paradigm, microservices. You hear more microservices influencing on the way you engineer software and also the way you compose them together quickly, rapidly, so to create reliable services. Then this IoT I will discuss more about, but as I said, Internet of Things is move from network of computers to network of everything. So that present another new opportunity. Then this big data, everywhere data is captured for various purposes, logs and IoTs, and everywhere massive amount of data is increasing. So much of log of data. What do we do with them? Making sense of the data. So then the serverless. When a person is composing application deploying, they don't need to think about servers and all. They simply focus on business logic. Let somehow it ultimately happen. So you don't think about any server anymore. So that model concept of serverless computing. Then this earlier virtualization was primarily on compute, but now it's shifted to also other elements of resources such as networks. So networks are getting virtualized not only within a data center, but across multiple data centers that are connected. So especially when you are thinking of mission critical application service delivery like remote surgery. So there you need a better way of allocating resources, bandwidth resources. Then of course these days you hear everywhere AI, artificial intelligence, that means like machine learning, deep learning, all these techniques. So there are numerous applications that can be composed to automate certain processes where generally humans are involved. So these applications have become so popular that now we have got a special purpose microprocessor designed for AI workload, like TPU, transaction processing unit. Earlier there was something called GPU. That means the computing system become really heterogeneous. A given node, a given compute node or a server will have GPU, TPU, so many micro, processing element. So as a result, it can be quite complex how to harness this power. So that is where software challenge comes into picture. So then the smart server application like smart home, smart hospital, and so on. driven by IoT. So these are other next. And then these days you hear term everywhere, something they call digitization. So everything hospital digitization. That means like hospital becomes smart hospital. So then healthcare applications become even more prominent. So we need a better way of managing this data, better way of ensuring privacy and so on. Plus this during last 18 months, this COVID-19 has caused a lot of problem everywhere. Still some cities are just getting opened up. Like, for example, we were discussing, Professor Sanjay and all, myself in the beginning, that the Melbourne is just opened up. So last almost 60, 70 days, it was fully locked down. So now it's just opening up. We hope that so this will come back to normal. So anyway, so the huge impact. But however, whatever is happening, the businesses are running, services are being delivered. So the key role played by IT technology, especially cloud and internet. So of course, internet is just a media, but service has to be on that service is hosted in cloud. So this, I think, popularity of cloud, usage of cloud has escalated heavily. It almost increased by whatever was there during late 2019 to now. If you see, it increased by 1.5 times. There's a huge usage of cloud, and more digital transformation applications are moving to cloud. So this is actually a good thing for people like us who are working in this research area. Then, of course, if we just think of AI applications are numerous domains, and applications in robotics, in healthcare, in surveillance, security, then of course e-commerce automation, then social media. There are so many applications. Now we find in AI, and all these applications are moving to cloud, especially when they are providing remote services. So these are hosted in cloud. So they are, as a result, you see the need for more advances in, cloud technology. So in that context, let me discuss now cloud architecture along with our Anika platform, how these trends, technological trends and other application trends influence on the architecture. And I will discuss in those contexts, along with those respective some application case studies, how these platforms and architecture is helping. So, a cloud architecture is market-oriented. Why should be market-oriented? Because the cloud is service that is offered to users on a subscription basis. You subscribe and use and pay for what you consume. Of course, the price they charge can be, can be varying, dynamic. During peak hours, it can be high, it can be low. And like this, there are multiple service providers, not just one. And each of those providers may charge different price for the same thing, same capability. So therefore, you as a user also want to optimize what services you want to consume and how you deliver. Then similarly, the providers also want to allocate services based on this price and so on. So therefore, market-based architecture is very essential in resource allocation, management, scheduling, and so on. So we will take a look at as we go along. So you can see in this environment at the bottom, there are several servers that are interconnected. Earlier virtualized, still virtualization is there, but now they become containerized. So that means when the user makes a service, so operating services come, maybe there are pre-created virtual machines are there. Quickly bring up this container hosting a service. So this user makes a request to cloud, and then of course the system looks into can this service be provided at the quality they're expecting. If yes, the request comes in. When the request comes in, the request is mapped to a virtual machine. So on a given physical machine, there can be multiple virtual machines. So also note that when you rent a capability in user compute, for example, there is no single server named after you. What they provide you a virtual machine, and this virtual machine is dynamically mapped to a physical machine based on various parameters and policies. But anyway, let us say your request is running on a virtual machine and it is serving users. With time, number of users will increase. And you can see even like when we started this conference, Zoom started, and only we were just few. Then slowly it is increasing. When number of users are increasing, if you continue to provide service using the virtual machines that are hosted, so you'll be not meeting the quality that is expected by the users. So this is when you need to dynamically provision extra resources within one cloud or multiple cloud, depending upon where users are coming from. If users are coming from all over the world, or maybe some users from this country, that country, then you need to provision and position them in such a way that each of those respective users get the best service. So that requires you to possibly harness multiple clouds. So right now, multi-cloud computing is a very popular, in industry. Then of course, when number of users decrease, what do you do? So you don't really stay at that level of resource allocation, you decrease it. So there is a shrink number of resources that are allocated for the application service. And by doing this, what would we achieve? So first we achieve resource efficiency. Means it is very important to make sure that resources are efficiently used. So that resource efficiency also means cost efficiency. You can offer services that are low cost possibly to end users. So if you are an application service provider, you don't need to rent too much. You just rent what is needed based on your demand on your application service. So that way you can save the cost, and then you can pass on a low. You can offer competitive low-level service, low-cost services to end user. Then other one is these cloud data centers consume enormous sort of energy, that electric energy to power them. A typical, like right now, the cloud data center worldwide, when you combine together, the amount of energy consumed by them is actually more than India. So India's energy, whatever that trillion watts, so much is consumed. So you can imagine these are power hungry. So we need to think of how to use them efficiently. So it is not about you may be having money, but it also has a carbon impact, climate change and so on. So these days we hear so much about what is called as climate change and something called net zero. In Australia, usually they ignore. In many countries they ignore, but now they're talking about net zero by 2050. Nobody knows what the net zero is, but basically what they mean is we will still waste, but we'll also try to create some efficiency. That way, our contribution to climate change will be a bit lesser than compared to what is happening right now. So anyway, this cloud data center consuming so much. So by 2030, it is projected that if you don't develop efficient software system application and the hardware, if you just leave it the way architecture is, the way things are going, the cloud data center will consume 20% of world energy by 2030. So there is also a lot of pressure on technology people, researchers, and technology one think about energy efficient services, efficient management. So this is another area. This is another area I can talk on for several hours. But right now we'll focus more on broadly, the architecture technology. So then coming to the software solution. So the conceptual understanding. So how can we make it possible? So let me, discuss about one of our own technology that we recently advanced, latest version of the software that has many of these features for multi-cloud computing and then healthcare application and delivering services as per the QoS requirement. So this Anika is a cloud application platform that allows you to rapidly create applications and deploy on multi-cloud as necessary, one or more cloud. So what are the key components this Anika has? The first one is SDK, Software Development Kit. So this SDK contains various models for application programming, APIs and tools such as thread model, task model, MapReduce, and few other productivity tools that you can use to build application rapidly. And once you build, you want to deploy. You should be able to deploy on a local area network of computers, or you deploy on one of the public cloud, or you deploy across multiple public cloud. And this should be seamless. As a creator of application, you don't want to worry about these low-level details. Application developer want to just focus on that application logic, but the system should do it for you. So that way you can be more productive application developer. So from that context, we have second component called runtime mercenary resource manager scheduler. So this is able to allocate right set of resources from right place based on requirement, and then deploy and manage execution and reduce and deliver the results to end users. So when we go deep inside this Anika, what does it contain? So this actually follows a container-based architecture, service-oriented container-based architecture. A container on each of the server can host different capabilities of Anika depending upon the needs. So there are foundation services that are offered. Then, of course, the application models are created on top of those foundation services. So that is why we see Anika as the world first software platform that supports multiple models of programming. Even today, you can't find in the market a platform supporting all these models in one SDK. So this is what Anika makes it unique. But of course, nowadays, slowly others also copying, but that doesn't matter. But this is the core innovation of this engine we created, 10 years ago, and also has a US patent already almost close to 10 years. So that is the innovation that Anika has. Then Anika Technology has been, we constantly advance this technology along with the newer policies, techniques, as as more and more newer trends and applications are coming up. So you can see our first version was almost 10-11 years ago, and then now we have got latest Anika 5G, fifth edition of Anika, very much supporting this what we call IoT and deep learning and AI application. Of course, this privacy-aware computation is also another popular area where you can do something, and people are doing along with Anika. So this Anika supports multi-cloud computing. So, but however, those of you who have some hands-on experience, you know that each of these cloud service providers, each of them actually they have their own way of spinning a virtual machine, the way of starting application task. So that means if you're just using raw infrastructure services, you have to build your application for each of the platform. So you don't worry. So Anika has adapters for different infrastructures like Azure, Amazon, OpenStack-based infrastructure cloud, or VMware. So like this, there are multiple cloud products. So we have created adapters, software adapters that work with each of these and then provide you a seamless interface. So you simply focus on application engineering. The rest is done by Anika. So this Anika, technology has been used by many, users, companies, and so on. Here are some I listed, but many more. So I will discuss briefly one or two, then leave it to you to look at more details. Okay, for example, the China Southern Railways for high-speed design. Then, of course, in India, Indian Space Research Organization, they use it for satellite, image processing that was created in Hyderabad. But you see, in ISRO having divisions across India, including one in Ahmedabad, SAC, Space Application Center. So they are developing these applications and deploying their application across multiple clouds. Like Anika is one of the platforms that can be somebody can use. Then Washington State University in the United States. So they use it for medical data analytics. When you're doing medical data analytics, there are a lot of privacy issues in data. So there are constraints on data movement. So if it is a data privacy, you can't even move the data to public cloud. So this is where Washington University has developed a plugin that analyzes the medical data and classifies them into private, sensitive, non-sensitive, and sensitive records are processed in public cloud using Anika, and non-sensitive ones are processed in a private cloud in a seamless manner. So this is from United States. Then, of course, IIT Delhi and in our colleagues in Melbourne University also developed many interesting applications in healthcare and deep learning, and also this COVID-19 Open Research Data Challenge. So this during lots of publications are there and how to do that analyze in timely manner. So I will discuss 2 or 3 of these examples a little bit more in depth. So this China Southern Railway, China Railways. So they are responsible for building high-speed train for China. So here is a traditional design scenario, different train design scenario, and then they use a software called Maya, and then rendering on this 4-core server. So this traditional approach on a single server was taking something like 1 day to like 24 hours to 4 days. So 80 hours, that was too much of time to wait for results. So they set up a Anika-based private cloud, enterprise cloud using our software. Then we have a tool called Design Explorer. So this Design Explorer is used to run this application on the enterprise cloud, and Design Explorer, is allowed them to explore, compose this Maya software for cloud processing as a SPMD model using SPMD model, single program, multiple data. So those of you who know computer architecture, so this SPMD, single program, multiple data, is one of the popular model used for concurrent execution of tasks. So this run, when they run, they were able to get results in a single server. What they took 4 days, same thing, they're able to get result in 2 hours. So you can see they're reducing the time to discovery from 4 days to 2 hours by harnessing a couple of servers inside the organization. So now 2 hours is sometime maybe too long to wait, right? So for example, India, so this high-speed train project to connect Mumbai to Ahmedabad, I don't know when it will happen, but anyway, such a train design, so is a favorite project of the current Prime Minister Modi. So if you visit your university, and then if you have such a design, and you want to show him, here is some other 2 design scenarios, that is half the price of what you are already trying to spend. So maybe they will be interested, but he can't wait for 2 hours. Perhaps you can make him wait for 10 minutes. What do you do? So within Anika, so we have this Design Explorer. There you set a QoS parameter. Click on the QoS parameter. Say deadline is equal to 10 minutes. And your local resource takes 2 hours. but you want answer in 10 minutes. What do? We can dynamically hire some extra resource from a public cloud that other providers are offering, like Amazon or some Century 21st cloud in Delhi, doesn't matter. So now you are hiring extra resource from outside, but that are not free. Okay, you have to pay for them. So therefore you said deadline is equal to 10 minutes and the budget is equal to 500 rupees. Correct? Because we don't have infinite, nobody has infinite money. If we have to be infinite money, then we will not have a finance minister at all. Correct? Infinite money is there. Why we need finance minister? You can give it to everybody. Similarly, here also we got the budget limit. Deadline is equal to 10 minutes, budget is equal to 500 rupees. Now, Anika on your behalf looks into marketplaces, then identify resources and based on your requirement. What is the company's requirement of this application within this timeline? How much resource we need? How much budget limit? If you give very less budget, you will say no, not feasible. Please increase the budget. All right. So, so if it is feasible, then on your behalf, you rent those resources and spread the computation across the resources you rented on your behalf, and then does the computation bring just back to user. So you can see, so such a model of computing requires you to build a resource management algorithms, scheduling algorithm that are cost aware, that are user requirements aware. And you see, some of our paper, deadline and budget aware scheduling, very detailed algorithm that tells you how we did it and how it deploys, then that minimize the cost of computation. So this is one of the very interesting approach that we followed. By the time, in real world, because we are doing both research and innovation, so generally, research is quite ahead. Then the deployed solutions that in the market is slowly they will take for 5 years. So this is the solution that within Anika that we are able to do. So that was for engineering. The similar thing you can imagine for ISRO also. Then here is a healthcare. I think today I will give more and more healthcare example. So because in people's mind right now, health services is more than money or any other. So healthcare, this is a ECG data analytics as a service. So ECG, like like electronic devices, ECG, they can monitor your heartbeat data. So these days, even the smart watches are coming. When you wear that watch, they monitor your heartbeat data. Right now, even the simple device you can put it to finger. So this data you capture, then you send the data to an app running on a mobile phone, and this mobile phone will send it to a cloud. Say, for example, on cloud here, ECG data analysis service running on Anika. It can running on a public cloud, private cloud, doesn't matter. So here is a service that users can make a request. So in this case, as I said, the application service can provide a QoS parameters such as deadline and budget as well. Somebody says, hey, I'm in criticality. I capture my data, emergency. Give me answer within 5 minutes. So they come with the request. And then, of course, then for which they pay 50 rupees. Then there may be other users, they're not in emergency. They say, give me results tomorrow morning. No hurry. Correct? For that, I'll only pay 10 cents, 10 paisa. Correct? So like this, different users are coming in. The system is able to allocate resources as necessary to make sure that if you admit the request, then you must provide. So this is another example of healthcare. And this is also demonstrated. You can see here. So here is the data captured from this person hand and send it to mobile phone. From mobile phone, we send somewhere in the cloud outside the conference hall, and the results came back. And then, of course, you can, in a healthcare area, you can just by looking at this graph, you can tell a lot about a person's health, including how many hours they slept yesterday night. So these are critical monitoring health, caring health. If something going to happen very dangerous in 1 month's time, we better identify symptom, not only do something about it. So this is an example of combining sensing, mobility, cloud, and analytics. So this used to be called a SMAC paradigm, SMAC, sensing, mobility, analytics, and the cloud. So all the things together. So this is one successful example of healthcare. Now let's take a look at AI application, for example. So this is deep learning for object detection. So these days, object detection application can be used in so many areas, in security, in enforcing rules and regulation, or in ensuring how systems are running, how safe is your places. Anyway, so these IoT devices like cameras everywhere, they deployed. They are everywhere, and they are constantly capturing videos and so on. And you want to detect the object in that scene or in that video. So this is usually done by using these deep learning algorithms. And so these deep learning algorithms, some of them are designed to run a single server, but we want to run it on multiple servers to give answers in real time. So here is there was a program called deep.py. It's a ready-made program. So some of the researchers from IIT Delhi, they took Anika Software and took the deep.py, then made this as an Anika-based task forming application. So this way, when request comes in, you farm out many deep.py tasks, and then they are running on either private cloud or public cloud as necessary. So here you can see the standard input image, the video input images on the left side of the computer lab at IIT Delhi. Then, and from there you are able to detect object. What are the object here? Oh, here are the computers, monitors, keyboard, mouse, and of course the people standing, people. And of course you can see how many people are standing in the lab also. Oh, nobody is using, but computers on, this will be turned off. You can use for various purposes. For planning, if somebody is taking away the computer, you can detect and catch them. So there are many applications you can do, but I want to highlight that this object detection, this is another work done by IIT Delhi researchers. So you can we have the software and also application code, the paper describing how this is done as well. So this is from AI application. Then this is my final example of Anika application, which is mining COVID research data challenge. So basically during last 18 months, so this was done a few months ago, but by this time already 200,000 papers are published, which are around dealing with COVID situation, including progress on vaccine, social distancing, then personal protection equipment, and so many papers are published. But if you are someone looking for, oh, give me top 5 papers related to vaccine, not only progress on vaccine, but also booster. Give me a vaccine that doesn't need a boosting. So like that. So if you do that on one single computer, it will take several hours. You want to get this answer quickly. So what we did was we created the machine learning application, take the data set, and then we created this task forming that analyzing that divide the data into multiple segments and process the needs of the task on each of the segment and give aggregate result in a timely manner. So this is a pipeline of showing so data capture to processing in parallel across multiple Anika based computation, then presenting results back to the user. So this kind of thing we did, and when we run it on single server, what used to take something like 20 minutes, and the same thing on a 5-core server, 5 servers, it took just 3 minutes. So of course, with that number of data items, when you increase, you need to have more nodes to to get your answer in real time. So this is another example of applying some of our solutions to any problem related to in the context of COVID data set analysis, or maybe healthcare applications and so on. So this is these are some set of applications. So this Anika software is commercially available through manjarasoft.com. I mean, Manjarasoft company. So this is our company that we founded from University of Melbourne to develop market and commercialize the solution. So right now we have got Anika 5.0. You can visit manjarasoft.com and then download Anika 5.0. There are so many students, for example, in India, just to give you confidence that they have downloaded and did very interesting work with this. Then, of course, in terms of teaching, educating students with skills in cloud application programming. So numerous universities across India have been teaching cloud computing courses. So here is a number of institutes in the country. So they have set up Anika-based laboratory and then able to teach application programming with hands-on, not just teaching theory, but also practical hands-on laboratory. So many of these are already doing across the country, all the way from Punjab to Tamil Nadu, and then from Maharashtra to Meghalaya. Okay, so it's very fascinating to say from Kashmir to Kanyakumari, correct? And then from Maharashtra to Meghalaya. I think that sounds better. So so there are a number of institutes have been teaching already and doing research and publication in this area. So that's about Anika, I mean cloud. But what you see is some of the applications which are based on IoT, but they were cloud centric. But now this IoT trend is changing. So what is changing? By 2030, you will say, it's expected that something like more than 500 billion object part of internet. You see right now just maybe not even billion computers, but you see more than 500 billion objects become part of internet. There is massive amount of data captured, and they all want to be analyzed on a cloud. That model is not good, because if everybody puts to the cloud, the internet gets clogged. But anyway, the good thing is if such a solution, IoT-based applications are there, then that creates a huge opportunity. It seems by 2025 it is projected to be something like $11 trillion, trillion, billion and trillion, like crores, and then billion and then trillion. It's a huge amount. You can't think of. So such a big business opportunity there. Why is there such a big opportunity? Because of these applications of this IoT, mobility, and cloud integrated solutions in so many areas, including applications that we don't even think of today, such as this what they call connected cars or autonomous vehicles. Yeah, so this is like you say, I'm at Swaminarayan temple in Ahmedabad. I want to go to airport. Simply say you don't need a driver, just put in a car and that will take you to airport. Yeah, so the driverless car. So such a smart car transport system. Like smart healthcare, smart homes, and smart grid. There are so many areas. Everything smart these days. Even the city is smart. People talk about smart country. So anyway, the mobiles we say smart. Everything smart. But in the process, people are becoming dumb. They're saying machines are learning, humans are not learning. Humans are forgetting. So anyway, these are the applications. Huge opportunity in terms of an IoT-enabled economy. So this is good. So now, what do we do? How do we support this application? What kind of computing model we need? And the first one is the cloud-centric that we already discussed. The smart IoT devices, and then data analyze on the cloud, and then do actual actuation on the other side. The cyber physical system, combining cyber and physical world. So this model of this cloud-based architecture, the problem is with several hundreds of thousands of billions of objects pushing data to cloud, the internet get clogged, then the service latency will be very high. So you want a low latency services. What do we do? So this is where, instead of pushing to the cloud, we need to see an alternate architecture, like harnessing resources at the edge of the network. So each of these data generation places, there can be a small edge device that does that processing. Wherever necessary, it can use the cloud service also in a seamless manner. So either use the edge resources, or use core network resources, or cloud, or combine them as necessary. So this way we have got cloud-based IoT, then edge-based IoT, then fog-based IoT. Fog is more combining both edge and cloud. So these are the new computing. Edge and fog are the latest trends, which is essentially bringing cloud-like services to the source of the data. So in this conceptual realization, we developed a software called Fogbus. So Fogbus is a framework for creating edge or fog computing application. This framework also is embedded with blockchain. So because when you are having this kind of sensitive healthcare services, so you are sending data, you don't want somebody tamper the data that is flowing towards edge or cloud, nor the results tampering. So how do we do that? You can create a block of data, process, and results come back. If somebody has tampered with the data, the block is broken. Therefore, you can say I can't trust the result anymore. So the integration. So here this Fogbus comes with a component for device oximeter, and then there is a gateway machine like a smartphone. Then here is the Fogbus master, Fogbus workers running on lightweight, this like a Raspberry Pi. Then of course, when necessary, public cloud. So public cloud unification by Fogbus is done through Anika. So this is a combination of edge and local resources and cloud resources. So this Fogbus supports. So this Fogbus technology we apply to many applications, including this sleep apnea analysis. Like here is the oximeter. Oximeter is a simple medical device for something like 500 rupees. You can get, and if you put it just to hand, it captures the data. And with your local mobile phone running an healthcare app, so you can data is sent there, and then this can send it to your local edge or a cloud, depending upon how it is configured. So here is analysis of that sleep apnea is able to indicate whether the disease severity is a mild or a normal or a emergency. If it is normal, no need to worry. If it is mild, okay, you have to take care. If it is emergency, rush the person to hospital. So this also we demonstrated. You can see we connected that this device to the finger of the person, then the data captured and processed on the local Raspberry Pis, and then or a cloud, and results came back. So here, Raspberry Pi, some of you might have heard, it's just like a matchbox size computer, small matchbox size computer. So that means very inexpensive. So this can be very easily deployed in smart signaling system or smart roads and traffic, very easily affordable based. So this is a demonstration of that technology. Okay, so this Fogbus, of course, I mentioned about containers. So these days, container is also gaining very popularity. So we also added microservices based model extension to this Fogbus. So just released called Fogbus 2. Yeah, this is just recently done. So conceptually same thing, but built using microservices, which means it will allow you to better, software engineering, better reliability in services. So that is about real software for real application, real computers. But researchers, who are doing research on scheduling research and research management research, so they possibly may not have a time and energy to build up real platform and buy so many devices, IoT devices, and do real experiment. Very time consuming. For that purpose, computers and research people generally use simulation approach. So to help people, researchers, we develop this simulator called iFoxSim. For cloud computing, we have got something called CloudSim. So many of you probably heard about it, Cloud Simulator, CloudSim. So similarly for this fog-edge computing, we have this iFoxSim. So this provides you all those elements for simulating IoT devices, simulating fog devices, simulating the compute resources, sensors, and then after that you develop a policy on which is good one. Okay, so this is also available as open source software. And furthermore, we recently added a few more capabilities to this CloudSim, especially mobility. So if you want to simulate these autonomous vehicles, you need a mobility features as well. So this is mobility added to Anika. Then microservices, another one in a simulator. Then the clustering, because if you want to do some kind of AI ready-made few libraries, we provided. So this is the setup capability that I added to iFoxSim. This is just released. Paper is yet to be published, but we have put it online if you want to explore. Okay. So then finally, so this is my the final example of application drone based. So these days people also want to do something with drone, correct? So these drones can be used for so many purposes, for smart agriculture and this smart traffic patrolling, monitoring, or it can be used in military. So we recently, every now and then we hear there are some drones are sneaking from border country to India. So you see the drone base. But anyway, the drone base, we also thought, let's show it in the context of COVID-19. So during March and also last year, also this year, there was so much of lockdown in India, in Delhi, for example, Noida. So there we work with some of the colleagues. So Indian Robotic Society. So here the drone fitted with thermal camera. The people were in these are multi-story buildings in different apartments. So this drone is able to go around the building, and people are requested to come to the balcony. So the camera, that thermal camera, is able to see the temperature of different people standing there. So if somebody has a symptom like a COVID fever symptom, then perhaps quickly identify and then do some whatever medical thing necessary. So for that purpose, the data that is captured, so processing on an edge or processing on a cloud. So edge can be nearby, so you don't have to do too far. So if the drone is going around, so they can come with one box containing compute resources. So the drone data that is captured is sent to the nearby device, and the device can see what to do with the data, process, or wherever in cloud. So this is the integration of edge, cloud, and drone. So which we call drone-based network system for combating COVID-19 pandemic, and we published paper on this as well. So of course, deploying such a thing in a practical was demonstrated, but the same thing can be applied to, same model can be applied to other application areas. So that is about edge and IoT application. So I took example of drone and medical devices and so on to illustrate this concept. So to conclude, so there are several computing paradigms who have promised this vision of how to make computing as utility. And today we've got this cloud computing that made it really, not just a dream, but dream to reality. So it became real, and you can see so many applications already powered. by cloud services infrastructure, and these applications come from both healthcare, consumer domain, business domain, government application, all kinds of application. But moving forward, like this IoT and AI application, they are the major driver for advances in further advances in cloud. Then I talked about Anika as a platform supporting this rapid creation application, then deploying them on a multi-cloud with minimizing the cost and time. So this Anika is, primarily we started with, how do we create an application rapidly, minimizing the cost of software engineering, then the service delivery. So the Anika has been used in so many areas of application, including engineering, healthcare that we already discussed, but also in smart cities and business intelligence and gaming applications, so on. So in interest of time, I've just shown you one or two case studies. Then IoT, as we discussed already, first generation IoT applications were cloud centric. The next generation are, edge or fog centric. So as a result, you can achieve, real time services delivery due to low latency of services delivery. Then, of course, you can also reduce in load on the internet, especially upload traffic. So usually, most of you know that you have upload speed and download speed. Usually download speed is almost 90% faster compared to upload. And if IoTs are uploading so much, it will be a huge problem on the internet. So network problem. So having this edge integrated is better. Okay. So there are many open challenges as well. So 2 years ago, I worked with several researchers around the world, put together this manifesto for future generation cloud computing. So this manifesto is a 10-year, agenda identifying many open challenges in different aspects of cloud computing. I didn't touch so much about security. You can see security, privacy as a big issue there. So how to do that? So about this energy consumption aspect, then heterogeneity aspect, there are so many challenges are there. So I have basically covered high level and then talked about application solution engineering. But you can see there are many open challenges. In case if you want to do research or something in this area, you can take a look at this manifesto published in Asian Community Surveys. So those are you who are a bit new. So you can learn Anika programming through this Mastering Cloud Computing book. So this is American edition, probably $89, $90 or $100, bit expensive for India. Don't worry, we have made in India solution also. So McGraw-Hill published this book and available for $8, $9. So probably 500, 600 rupees, easily affordable. Yeah. So this is, maybe I should talk to this UP Secretary of Congress. What is her name? Gandhi? Rahul Gandhi, Priyanka Gandhi. To give out a free book if Congress wins, free books to everybody, all the girls. They want to give scooty and mobile phone. So I will make a deal with these IT companies, embed free along with that books. I think having the skills area, that will be long skill. This scooty and mobile phone will be thrown away in 3 years' time, but the book knowledge will come forever. Okay. Then we also have solutions for Chinese as well. And Chinese also, sometimes they can't afford this Indian price. So we have a Chinese solution on the same book in Chinese language. So this is for $3. So what I'm also highlighting is that when you think of creating cloud services, especially healthcare application, these areas, if you're targeting, for example, delivering service across Gujarat or across Tamil Nadu, you better off, charging prices in such a way that it's affordable to consumers. The people in the city of Ahmedabad, little bit higher, people in the villages, little lower. Okay, so this is an example how you can do it. So of course, for IoT edge computing also there are books, and here are some that are indicated here. So with that, let me stop here, and thank you very much for your patience hearing. And here I also provided you my contact email IDs. Those of you who don't know, so you can like for research collaboration purpose, you can use my Melbourne University email ID. Or if you want to set up an Anika-based lab or do something interesting entrepreneurship yourself, so you can email me on manjurasab.com, raj@manjurasab.com. So let me stop here. I think I would like to open up for more discussion. So this way, now we can have a better interaction among us. Okay. So thank you.
Thank you very much, Professor Buya, for sharing very interesting research details and ideas with us. Now, floor is open for question and answers. Participants can ask the questions through chat box.
Probably disable. Oh, it's enabled now. Okay. So can they type in chat box?
Yes, participants can post questions directly to host, and you can post to us also. Meanwhile, sir, let me ask you a question related to Anika.
Yes.
Anika is actually really interesting application, and it allows us to interact with all major cloud platforms. So my question specifically from student point of view, what are the prerequisites for our students to start application development using Anika?
Okay. So
Any specific prerequisites?
So especially
need
let us say
to
students
be
are in the
aware
final
of?
year. Yeah, those who are in the final year, they would have already had a basic computing programming, and then they would probably know already Java, C++, and other languages. So they would have actually heard about, maybe multi-threading in Java if they have done it. If they have not done it, that's okay. So in the final semester or final year, like a third year, fourth year, or a third year final. So there we can set up Anika based lab. So Anika, as you can see, the book is there. The programming perspective. So in the beginning, so somebody has set up this facility for them, and they can simply focus on programming. So using Visual Studio, for example, so they can develop threaded application using Anika. So just like they can do multi-threading in Java, same thing you can do multi-threading in using Anika's APIs. So then their application automatically start running across multiple cores or multiple servers, depending upon the infrastructure that you set up. Then, of course, this thread map reduce is another model. So they'll already explain nicely within the book. So I can say the basic the computing knowledge, then of like what is taught in computer science. Say engineering degree, fourth year, like 7 semester, 8 semester students can easily manage it. So many of them are already doing this way.
Thank you, sir. Just to in continuation with that question, do we need any specific hardware configuration to for development of this?
Okay, good. So for example, if you already, so those who already have a, for example, so Windows based PCs LAN connected, so you can load Anika container on multiple of these and make one of them as Anika master, the rest are Anika workers. The user's account submit their application that they create and run it through this master on all those servers, all those computers that are part of the network. That is a very simple configuration. Of course, if you create our own dedicated cloud services using, say, you create an infrastructure service using, say, OpenStack, you can run Anika there, spinning multiple virtual machines that are running Windows software. So it works on both Windows and Linux environment. So let's say we start with EG. In India, most departments have got a computer lab, LAN connected already. They are already running Windows. So we can roll Anika on this and then get things going. So it is very simple. There's a lightweight, very minimal entry, minimal barrier to entry.
Sir, I'm Dr. Sendil Kumar. Just a simple question, sir. Hello, can you hear me, sir?
Yes.
Sir, what is the role of Anika cloud application platform in growing market?
Yes. So, Anika itself is, we sell it commercially. But if somebody has developed a application solution on top of Anika, so they can definitely make it available to the market by having their own, say, small scale cloud environment and start offering services. So, and then this concept of market-oriented cloud computing is different from taking it to the market. So when I say market, means like in market the prices are there, different users charge different prices. If you are someone want to use multiple cloud, so you can actually also think of using cost efficiently. Like if you are a application service provider, so you are using multiple infrastructure service from different vendors. You don't want to spend too much. You don't want to unnecessarily create virtual machine and pay for it. So Anika will help you to do that on your behalf based on actual demand on your application services. That is a technological solution.
Thank you, sir.
Clear?
Clear, sir. Thanks a lot, sir.
So, Professor Bhuya, I have one question and I can raise on behalf of students. See, when you started developing this Manjaro Soft and Anika, at that time, technology complexities were different. And today, technology complexities are of different scale, depth of technology is also different. how come your product, I would call a complete product or complete suite, how come you are able to successfully continue, or how come your product is able to get various aspects of not only cloud computing, IoT, drone, all those interfaces are successful with your product? So what challenges you tackled, and how you tackled those challenges?
Yes, so going back like 10 years ago, so at that time, we ourselves had something called Alchemy. So Alchemy was supporting one of the model of programming. Then we were looking into extending the Alchemy for multiple model of programming. So that was not possible. So from that experience, we thought, okay, we will create a next generation solution of the Alchemy. And then we were doing a lot of research on the other side on this modeling and simulation. So we architected our solution in such a way that we separated out the foundation services, the container, and the applications. So this way we can create thread, task, map, whatever available coming up. So the foundation service. Once we have foundation services, we are able to showcase, okay, let's do it thread, done. Then task, done. Then map is done. And tomorrow somebody says, hey, I want to do something for IoT. Okay, all right, no problem, we can create one. So that is the approach we take, extensibility approach in the engineering. And then, of course, we also want to make sure that, dominant two operating system, that was Windows and Linux, our Unix class system. So we wanted to architect in such a way that it works on both platforms, Unix class or Windows class. So this is where we built on top of .NET. So for my Windows, my .NET, for Unix and Linux, we went for that Mono. Mono is actually .NET compatible. But now the this .NET, I think 5 or 6, the latest Microsoft one, it works for both Linux and Windows. Because earlier Microsoft said, okay, here's the standard .NET architecture and the protocols. Then let open source community can implement if they like. And Mono came into picture. But now I think since arrival of this new CEO, our Indian-born CEO, what is his name? From South India.
Satya Nadella.
Satya. So Satya has become truly Satya. He's supporting both Windows and Linux. So therefore, Microsoft .NET framework is also now working across both. So that way, there is the heterogeneity of OS is supported. Then as we move along, the different companies, for example, infrastructure, this for Azure, Microsoft Azure infrastructure service. So Azure architecture for 1.0 and 2.3.0 we see is completely different interface. If you have built application for that 1.0, you can't run it on 2.0. So therefore, we were having all expertise on how to engineer this extensible architecture. We can simply focus on creating a plugin for 1.0, plugin for 2.0, plugin for Amazon, plugin for, like, once we create a plugin, so the developer application, no need to worry about that. Yeah. So of course, as the field progresses, as our research progresses, we quickly implemented those scheduling or resource allocation algorithm. So we also created this open scheduling APIs. So the scheduler that is plugged to Anika. So we created those APIs. So this way one can create different scheduler. So all these open interfaces allowed us to be more forefront. Of course, since this is a research-driven, the research is so much close to our heart, so we quickly implement. But it takes, maybe another 5 years or so for commercial product to have many of these features.
Thank you, Professor Bhuya. Such a fascinating journey, and you are so energetic for this particular technology. I'm really surprised to look at your contribution and your vision, actually vision in the domain of cloud computing. Thank you very much.
You're welcome. I think students are silent.
Do you have any question now?
Maybe you can request Dr. Senthil Kumar to thank Professor.
Now? Thank you, sir. Now, thank you very much. Now I invite Professor AVK Senthil Kumar for concluding remarks and vote of thanks. Professor Kumar, over to you.
Thank you. Thank you, sir. So very good morning to all. It gives me immense happiness to deliver the concluding remarks for this wonderful and memorable event. Dr. Rajkumar Bhuya's talk on Neoteric frontiers in cloud and edge computing was an excellent one. He has deliberated a talk that is the need of the hour. I thank Dr. Rajkumar Bhuya for accepting this invite to deliver the expert talk to the faculty and the student community for the knowledge and skill upgradation. I once again thank him for sparing his valuable time by immediately accepting the invites. I hereby also thank the organizers at Ahmedabad University for collaborating such a wonderful event with the PG and Research Department of Computer Applications, Hindustan College of Arts and Science, Coimbatore. I thank all the participants for the virtual presence and their active participation. Thank you all.
Yeah, thank you.
Thank you, sir. Thank you, sir.
Thank you.
Thank you, sir.
We'll be in touch. I will communicate further with you, Professor Bhuya.
Sure, definitely. Thank you very much.
Thank you, sir. Bye. This meeting will end now.